Here's a puzzle for the start of electricity. You are given 9 objects, A through I. You hold them near each other and you check whether the 2 objects attract each other, repel each other, or do neither. And you get these results. What can we tell about these objects? A attracts B and C, it repels D and E, it attracts F, G, and H, and does nothing with I. In fact, I does nothing with anything. I seems to be completely inert. Now B repels C, attracts D and E, repels F, attracts G and H. In fact, if you notice, everything seems to attract G and H. Now C attracts D and E and repels F. D repels E and attracts F. So if we look at things that repel each other, A and D and E are all in a group that they all repel each other. B, C, and F all repel each other. And it turns out that anything in this group attracts anything in this group. All of these will attract G and H, except if you put G and H together, nothing happens. And then I is basically in a class by itself. What does this mean? Well, you might guess that A, D, and E are all positively charged because they're all repelling each other. And B, C, and F are all negatively charged. They all repel each other. And anything positive and anything negative attract. That all checks out. But for all we know, A, D, and E could be negative. And B, C, F could be positive. They faced that problem when they were first developing this. And Benjamin Franklin just made an arbitrary choice and said, I'm going to call that positive. And we really wish he'd chosen the other way, because it turns out it's electrons that travel, and according to his standard, they're negatively charged. Oh well. But what's going on with G and H and I? G and H are attracted to anything charged, but they're not attracted to each other, and they don't repel each other. G and H are what we call conductors, because a conductor can feel an attraction to either a positive or a negative, because a conductor is made out of both positives and negatives, and it will rearrange itself to be attracted. I, however, does nothing whatsoever. So I would be an insulator. So we have 3 charges here that are either positive or negative, but all the same. These 3, which are the opposite charge. These 2 are conductors, and this is an insulator. G, H, and I are all what we call neutral. They don't possess a charge of their own. G and H are neutral conductors. I is a neutral insulator.